My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Database Management System as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2 first important short question is: define the relational model. Relational model. The relational model is a way of organizing data in a table format. In this model, all information is stored in relations, tables, and each table has rows, records or tuples, and columns, fields or attributes. It was introduced by E.F. Codd in 1970 and is widely used because it is simple and easy to understand. Each row represents a single record, and each column represents a property of that record. Every table has a primary key, a unique value, to identify each row. Relationships between tables are created using foreign keys. Example: consider a table students. Student underscore ID name class age. 1 Rahul 1015. 2 Priya 914. Here, student underscore ID is the primary key, and we can link this table to others, like marks, using keys. The relational model is popular because it is simple, organized, and easy to manage using SQL. Next important short question is: 2. What are null values in relational databases? Give an example. Null values in relational databases. In a relational database, a null value means that no data is available for that field. It is not zero, not a blank space, and not nothing. It simply shows that the value is unknown, missing, or not applicable. Null helps keep the database flexible because sometimes we may not know all information at once. Example: consider a table employees. EMP underscore ID name phone email. 1 Ramesh 98765432210 ramesh@mail.com. 2 Anjali null Anjali @mail.com. Here, Anjali's phone number is null because it is not available right now. Key points to remember: null is not equal to 0 or an empty string. We use SQL commands like isNull or isNotNull to check null values. It makes the database realistic by handling missing information. So, null values are a simple way to show no data yet clearly. Next important short question is: 3. List the fundamental relational algebra operations. Fundamental relational algebra operations. Relational algebra is like a toolbox of operations to work with tables, relations, in a database. These operations help us retrieve, combine, and modify data easily. Here are the fundamental operations. 1. Selection, sigma. Picks specific rows from a table. Example: get students with marks 80. 2. Projection, pi. Picks specific columns from a table. Example: show only names and roll numbers. 3. Union. Combines rows from two tables, removing duplicates. Example: list all students from class A and class B. 4. Set difference. Shows rows in one table but not in another. Example: find students in class A but not in class B. 5. Cartesian product times. Pairs every row of one table with every row of another. Example: match students with all subjects. 6. Rename, row. Changes table or column names for clarity. These operations are the foundation of SQL queries, making it easier to work with large databases. Next important short question is: 4. Write the basic structure of an SQL query. Basic structure of an SQL query. SQL, structured query language, is used to store, manage, and retrieve data from databases. The basic structure of a simple SQL query is: select column 1, column 2. From table underscore name. Where condition. Group by column. Having condition. Order by column. Explanation of parts. 1. Select specifies the columns you want to see. 2. From tells which table to take data from. 3. Where filters rows based on a condition. 4. Group by groups rows having the same values. 5. Having applies conditions on groups. 6. Order by arranges results. ASCDSC. Example. Select name marks. From students. Where marks 80. Order by marks DSC. This query will show names and marks of students who scored above 80, sorted from highest to lowest. Tip. Think of select as what to show, from as where from, and where as which rows to pick. This structure makes writing SQL easy and systematic. Next important short question is: 5. What are aggregate functions in SQL? Aggregate functions in SQL are special functions used to perform calculations on a group of rows and return a single value. Instead of working on individual rows, they summarize data from multiple rows. Common aggregate functions. 1. Count counts the number of rows. 2. Sum adds up numeric values. 3. Average finds the average of values. 4. Max finds the highest value. 5. Min finds the lowest value. Example. Select count asterisk as total underscore students. Average marks as average underscore marks. Max marks as highest underscore marks. From students. This query shows the total number of students, their average marks, and the highest marks in the students table. Tip to remember. Think of aggregate functions as math tools for your table. They summarize data and give quick insights without checking each row one by one. Next unit 2. Long questions. First important long question is: 1. Explain the structure of relational databases with examples. Structure of relational databases. A relational database is a way to store and organize data in the form of tables. Each table looks like an Excel sheet with rows and columns. This structure makes it easy to manage, search, and update data. Key parts of relational databases. 1. Tables, relations. The database is made of tables where data is stored. Each table has rows, records, and columns, fields. Example, a student's table may have columns like student ID, name, class, and marks. 2. Rows, tuples. Each row represents one record. Example, 1. Ali, 10th, 90 represents one student. 3. Columns, attributes. Columns define what data is stored. Example, the column marks stores student marks. 4. Primary key. A unique identifier for each row. Example, student ID is unique for each student. 5. Foreign key. Used to connect data between tables. Example. Course ID in the students table links to the courses table. 6. Relationships. Tables are linked through keys to avoid duplicate data. This makes databases organized and efficient. Example of relational database. Students table. Student ID, name, class, marks. 1. Ali 10th 90. 2. Ria 10th 85. Courses table. Course ID, course name. 101 Math. 102 Science. Here, student ID is a primary key in the students table and course ID is a primary key in the courses table. Linking them creates relationships between students and courses. Easy tip: think of a relational database as a school record book where every page, table, stores different information, but all pages are connected for easy reference. Next important long question is: 2. Describe fundamental, additional, and extended relational algebra operations in detail. Fundamental, additional, and extended relational algebra operations. Relational algebra is like a mathematical language used to get data from relational databases. It works on tables, relations, and gives a new table as a result. 1. Fundamental operations, basic building blocks. These are the most important and commonly used. 1. Selection, sigma. Picks specific rows from a table based on a condition. Example, get students with marks 80. Sigma marks 80 students. 2. Projection, pi. Picks specific columns from a table. Example, show only name and marks. Pi name, marks, students. 3. Union. Combines rows from two tables, no duplicates. Example, combine students from two sections. 4. Set difference. Finds rows present in one table but not in another. 5. Cartesian product times. Combines all rows from two tables, used to form relationships. 6. Rename, row. Changes the name of a table or column for better understanding. 2. Additional operations. These make queries easier. 1. Intersection. Finds common rows between two tables. 2. Join. Combines tables based on a related column. Example, match student ID in students and courses. 3. Division. Finds rows in one table that match all rows in another. 3. Extended operations. These are advanced features used in SQL. 1. Aggregation. Performs calculations like sum, average, count. Example, average marks of students. 2. Grouping. Groups data based on columns. Example, group students by class. 3. Sorting. Arranges rows in ascending-descending order. Easy tip: fundamental operations are like ABC, must know. Additional operations are shortcuts for complex queries. Extended operations help in reports and summaries. Example, if we want names of students scoring above 80 marks, grouped by class, we use selection, sigma to filter marks. Projection, pi, for names. Grouping for class. Next important long question is: 3. Discuss the data definition language, DDL, in SQL with examples. Data definition language, DDL, in SQL. Data definition language, DDL, is a part of SQL used to define and manage the structure of a database. It lets us create, change, or delete databases, tables, and other objects. DDL focuses on the design of the database, not the data inside it. Think of DDL as blueprints for building a house. You decide the rooms, walls, and layout before adding furniture, data. Key DDL commands. 1. Create. Used to make new databases or tables. Example, create table students. Student ID int primary key. Name varchar 50. Age int. Marks int. This creates a table named students with columns for ID, name, age, and marks. 2. Alter. Used to modify an existing table, like adding or changing a column. Example, Alter table students add email varchar 100. Adds a new column email to the students table. 3. Drop. Deletes a table or database completely. Example. Drop table students. Removes the students table permanently. 4. Truncate. Deletes all rows in a table but keeps the structure. Example. Truncate table students. Clears data but keeps the table ready for new data. 5. Comment. Adds comments or notes to database objects for documentation. 6. Rename. Changes the name of a table. Example. Rename table students to learners. Easy tip to remember. Create. Alter. Drop. Truncate. CAD plan, change, delete, or clear. Why DDL is important? Helps in designing a well-structured database. Makes changes easy as the system grows. Keeps database objects organized. Next important long question is 4. Explain how set operations are performed in SQL with suitable queries. Set operations in SQL. Set operations in SQL allow us to combine the results of two or more select queries. Think of it like math sets. We take two groups of data and find their union, intersection, or difference. These operations work only when the number of columns and their data types are the same in both queries. 1. Union. Combines rows from two queries without duplicates. Example. Select name from students. Union. Select name from teachers. This gives a single list of names from both students and teachers without repeating names. 2. Union all. Combines rows from both queries with duplicates. Example. Select name from students. Union all. Select name from teachers. If a name is present in both tables, it will appear twice. 3. Intersect. Shows only common rows between two queries. Example. Select name from students. Intersect. Select name from teachers. This displays names that are in both students and teachers tables. 4. Except or minus in some databases. Shows rows in the first query but not in the second. Example. Select name from students. Except. Select name from teachers. This lists names present in students but not in teachers. Easy tip to remember. Union, add together, no duplicates. Union all, add together, with duplicates. Intersect, common items. Except, difference. Why it's important? Helps merge data from multiple tables. Makes reports easier to create by comparing different datasets. Works like Venn diagrams in math, making concepts easier to visualize. Next important long question is 5. Explain modification of databases, insert, update, delete in SQL with examples. Modification of databases in SQL. In SQL, modification of databases means changing the data stored in tables. There are three main commands for this: insert, update, and delete. These commands help keep the database accurate and up-to-date. 1. Insert. Used to add new rows to a table. Example. Insert into students, student ID, name, class, marks. Values 1. Ali, 10th, 90. This adds a new student record with ID 1, name Ali, class 10th, and marks 90. 2. Update. Used to modify existing data in a table. Example. Update students. Set marks is equal to 95. Where student ID is equal to 1. This updates the marks of the student with ID 1 to 95. Always use where to avoid updating all rows by mistake. 3. Delete. Used to remove rows from a table. Example. Delete from students. Where student ID is equal to 1. This deletes the student record with ID 1. Like update, always use where to avoid deleting all rows. Tips to remember. Insert add new data. Update change existing data. Delete remove data. Real life example. Think of a school register. When a new student joins, insert. When a student's marks change, update. When a student leaves, delete. Important points. 1. Always check your where clause in update and delete to avoid mistakes. 2. SQL modification commands do not change the table structure, only the data inside it. 3. These commands help teachers, banks, or any organization keep records accurate and current.